students, we will see Kruskal algorithm in this lecture. Before going to Kruskal's, we have to see certain terms. Let's see them. The first is spanning tree. So what is a spanning tree? A spanning tree is a tree which spans all the vertices of a graph. So if you are given a graph, for example, this graph is given, then a spanning tree is a tree. So we have to choose some edges. Why? Because a tree is a minimally connected graph. So we should have minimal edges. And what are the minimal edges? If we have V vertices, then a tree will have V minus 1 edges to make it minimally connected. We can see this. Suppose I have 2 vertices, then I need only 1 edge to connect them minimally. If I have 3 vertices, then I need 2 edges to connect them minimally, because if I connect it like this also, then this is not a minimally connected graph. So the spanning tree that we can get out of this is, so these 3 spanning trees can be made out of this graph. These are spanning trees. Now edges ought to have some weight, and using that weight we can come on to our next term, minimum spanning tree. It is sometimes also called minimum weight spanning tree. So given that we have a graph having, let's say, 3 vertices and 3 edges, and the weight of the edges are 1, 2 and 3. So let's again make the spanning trees that we were making. So there will be 3 spanning trees like this, and let's weight the edges also 1, 2, 3, 2, 1, 3. So a minimum weight spanning tree is a spanning tree in which sum of all the edges are minimum. So there are 3 spanning tree possible from this graph, and the weight of this is 1 plus 2, which is 3. The weight of this spanning tree is 2 plus 3, which is 5. And the weight of this spanning tree is 1 plus 3, which is 4. So out of these 3, the minimum weight spanning tree is this one. So this is the minimum spanning tree of this graph. There can be more than one minimum spanning tree if there are more than one edges having the same weight in a cycle. So there are different methods of finding minimum spanning trees. We are going to see 2 methods basically. One is Kruskal's and one is Prim's. So in this video lecture, we will see Kruskal's. Kruskal's and Prim's both are greedy approach to solve minimum spanning tree. Let's take this example. We have 6 vertices and 9 edges, and the weights are given on top of each edge. Now I want to use Kruskal algorithm and want to find the minimum spanning tree of this graph. So what Kruskal algorithm does is it sorts the edges in increasing order of their weight. So if we see, we will have edges like this, U, V and W. 0 to 1 we have 1 weight, 1 to 5 we have 2 weight, 0 to 5 we have 3 weight, and like this all the edges are in sorted order. Now what it does is it creates a graph in which there are only vertices and no edges. One by one it picks the edges in the increasing order of their weight and adds it to the graph. And if the edge is not creating a cycle, then it remains added in the graph. Otherwise, it will be removed. So first we will see 0 to 1, 1. So if I add a edge from 0 to 1, it will not create a cycle. So this will be taken and we will have 0 to 1. Then 1 to 5 we have weight 2. So if I add a edge from 1 to 5, it will not create a cycle. So this will also be taken into minimum spanning tree. Next 0 to 5, 3. So if I add a edge from 0 to 5, it will create a cycle. So this will not be considered for minimum spanning tree. Then comes 1 to 2 with weight 4. So 1 to 2, if I add an edge, it will not cause any problem. It will not create a cycle. So this will be taken into the graph. Then 1 to 4, 5. If I add 1 to 4, then there is no cycle. So this will also be considered. Then 4 to 5 with weight 6. If I add 4 to 5, it will create a cycle between 1, 4 and 5. So this will not be considered. 2, 4 and 7. If 2 and 4 are connected, then it will create a cycle between 1, 2 and 4. So this will not be considered. 2 to 3, 8. If I add 2 to 3, this will not create a cycle. So this will be considered. And 3 to 4, 9. If I add 3 to 4, then it will create a cycle between 1, 2, 3 and 4. So it will not be considered. And if you weight them, this is 1, 2, 4, 5 and 8. So the minimum spanning tree has weight 1 plus 2 plus 4 plus 5 plus 8, which is 20. Now you cannot get any spanning tree having weight less than 20. So this is how Kruskal algorithm works. And now you may be wondering how we are detecting a cycle. We are not using DFS to detect a cycle. If you go one lecture back, you will see that we have studied disjoint set data structure to detect cycle. So that we will use in Kruskal's algorithm to detect cycle. Now let's see the code. This is the code for Kruskal's. Basically, here what I am doing is, because this is a pretty long declaration, vector pair int int. So I am type-defing it with VIII. This is my weight of the edge. This is my source and this is my destination. So this is how I am creating a graph. Let's start with the main. So here I am creating two graphs. One is G, one is RES. So RES will be used to store the result of a Kruskal algorithm, and G is my input graph. So here I have taken V and E. V is the number of vertices, E is the edges. So when I take the input VE, after that I am taking the source, destination and weight of each edge, and I am pushing it to my graph. So G dot pushback make pair. First is weight, as I told you that first is weight. So make pair W, and then there is a pair of source and destination. Then I am saying RES equals to Kruskal C comma V. Also, what I am doing is I am printing each edge, source and destination of each edge in the resultant graph, and the sum of all the edges, sum of weight of all the edges. So here what I'm doing, I'm taking W as resi dot first because the first one is the weight, and then I'm printing on the screen the resi dot second dot first because it is the second pairs. This is second, and its first is my source, its second is my destination. So res I dot second dot first, res I dot second dot second, and then adding W to the sum and then printing the sum. Now let's see what this Kruskal function is doing. So we are using here the find and union by weight method that we have seen in the previous class. So I'm not again showing it here. So it is showing it is first taking int parents and making every parent as -1. Then we are sorting the graph based on weight. So I have not passed here on which parameter I want to sort it. So by default, the sort function takes the first thing that it sees. So here the first thing is weight. So it will automatically sorts the graph according to weight of the edges. And then what I'm doing is I'm taking out SD and W, and if find S comma parent is not equal to find D comma parent, it means both representative element of S and D are different. It means they belong to different set. Then I'm pushing the current edge into my result, and I'm performing a union on S comma D. After all the edges are seen, we just return it. We just return the result. And this is how we perform Kruskal algorithm. So first we sort it. So sorting will take, basically because there are E edges, so it will take E log E. Any comparison based sort will take E log E. And this whole thing is taking, if find is like, let us suppose the find and union are somewhat constant because they are going just constant steps. So this will take, the whole thing will take big O of E, and the time complexity will be big O of E log E plus E, which will be ignored, and the space complexity will be big O of V because we are using this parent matrix. Okay, try this and try to run this code. Thank you.